Hello friends, welcome to the video tutorial on Firebird 5 robotic research platform. This platform is based on Atmega 2560 microcontroller which belongs to AVR architecture family. In this tutorial, we will learn pulse width modulation on Firebird 5 using Arduino IDE. Now, let us see the agenda for discussion in this tutorial. The presentation will start with the discussion on pulse width modulation and duty cycle. Then, we will learn PWM for DC motor speed control using Arduino IDE. Also, we will learn PWM for servo motor using Arduino IDE. PWM is a process in which the constant frequency square wave duty cycle is modulated so that power delivered to the load without loss. It is a technique for getting the analog result with digital means. Few examples where PWM is used are variable speed control for motors, lamp dimmers, generating audio signals, etc. Here we can see a signal in the form of pulse which is on and off for certain time. T-on is the time for which pulse is high. T-off is the time for which pulse is low. Total time period T of pulse is addition of T-on and T-off. Duty cycle is defined as ratio of T-on by T. Let us now see DC motor connection with Firebird 5. Direction control pin of two motors are connected at port A using L293D driver IC. Left motor pin 2 is connected to PA0 which is digitally mapped as D22 in Arduino. Left motor pin 1 is connected to PA1 digitally mapped as D23. Right motor pin 1 is connected to PA2 digitally mapped as D24. Right motor pin 2 is connected to PA3 digitally mapped as D25. Two pins for enabling the motor driver IC are connected on port L. Left channel enable and right channel enable used to enable left and right motor are connected to PL3 D46 and PL4 D45 respectively. Now let us understand function analog write. This function is used to output a PWM signal. It writes an analog value to PWM pin. The function is written as analog write pin, duty cycle. This function has two parameters. First is pin, the Arduino pin to write to 34, low, and second is duty cycle which is an integer value between 0 and 255. After the call to analog write, the pin will generate a steady square wave of specific duty cycle. It can be used to drive a motor at various speeds. Now let us proceed with writing the Arduino sketch to move the robot forward with 75% duty cycle for 1 second and stop for 1 second. Program begin with initialization of motor pins and PWM pins. For left motor, digital pin 22 and 23 are initialized as left motor pin 2 and left motor pin 1 respectively. For right motor, digital pins 24 and 25 are initialized as right motor pin 1 and right motor pin 2. Two PWM pins are assigned for motor control at D45 and D46 and are named as PWM1 and PWM2. After initialization of pins, we shall define forward function, which includes logic to rotate two motors simultaneously by writing digital write left motor pin 1, high and digital write right motor pin 1, high. Thereafter, we shall configure motor pins as output because motor is an output device. Also, PWM pins need to be configured as output by using function pin mode with parameter pin and mode that is output. PWM1 and PWM2 are the enable pins which are used to control the speed of motors. Next is the main code to be written in the loop section of the sketch which will run infinitely. This part includes the logic to move the board forward for 1 second with 75% duty cycle using analog write function to write the PWM value 192 on the pins PWM1 and PWM2. The value 192 is required to generate PWM signal of 75% duty cycle and stop it after 1 second by writing the value 0 on PWM pins. Here we have written the code in Arduino IDE for speed control of DC motor of Firebird 5 using PWM. Robot moves forward with 75% duty cycle for 1 second and stops for 1 second. A servo motor is an actuator with a built-in feedback mechanism that responds to a control signal by moving and holding a position or by moving at a continuous speed. It mainly contains DC motor, a gear train with proper gear ratio, a sensor for position feedback. Generally, it is done by coupling it with the potentiometer and control circuit to form a closed loop control system. Let us now understand how servo motor is controlled using PWM. Servo control is done by sending a PWM signal to the PWM input pin of the servo motor. The servo motor compares this signal to the actual position of the servo and adjusts the angle of servo motor accordingly. Position of the servo motor is determined by the pulse width of the waveform, which has frequency between 30 Hz to 60 Hz. Generic servo motor gives 0 to 180 degree rotation for pulse width of 1 to 2 milliseconds. 50 Hz is considered as ideal frequency. Now, let's see how to operate a servo motor. Servo motor is driven by particular angle by the control signal sent to it by a controller. These signals are basically pulse width modulation wave, and the angle of rotation is determined by the on-time period of signal. Values of on-time for servo for 0 and 180 degree are provided by manufacturer in datasheet. The pulse width may change for different types of servo motor. This time period depends on servo used and not on the total time period or the duty cycle of PWM signal. Graph of the on-time period versus respective angle is linear, so values of the time period for the angle other than this can be easily calculated by getting the equation of the line from the given two values. This slide shows the diagram of servo connectors. The ground pin is generally brown or black in color. Power pin is generally red in color, while the signal is typically white or yellow in color. Now let's move toward the interfacing of servo motor with Firebird 5. 3 servo motors can be connected at port B. Servo 1 is connected to PB5, which is digitally mapped as D11. Servo 2 is connected to PB6, which is digitally mapped as D12. Servo 3 is connected to PB7, which is digitally mapped as D13. The figures show how to insert the connector in the Firebird 5 robot. Let's now learn the Arduino servo library used to control servo motors using Firebird 5 and Arduino IDE. For programming servo, we shall need following 3 components of the servo library. First, create an object of servo with name myServo. Next, attach the object with servo pin using attach function. Finally, send the control signal on PWM pin using write function. Now, we shall understand the function attach, which is defined in Arduino servo library. Purpose of the function is to attach the servo variable to a pin. The function is called with servo object and parameter pin. This function has 2 parameters. First is servo, a variable of type servo. Other parameter is pin, which is the number of digital pin where the servo is attached. Next is write function. Purpose of this function is to write a value to the servo, controlling the shaft accordingly. The function is called with servo object and parameter angle. This function has 2 parameters. First is servo, a variable of type servo. Other parameter is angle, which is the value to write to the servo from 0 to 180. Let us now understand step for programming. Include library servo.h, which contains function required to control servo motor. Create a servo object to control servo. Attach the servo variable to a pin D11 to the servo object. Logic to control the servo motor from 0 to 90 degree. Now let us see the Arduino sketch to rotate the servo motor by 90 degree. It begins with including servo.h Arduino library used to control the servo motor. myServo is an object of type servo. Now we define a variable POS which defines the position of a servo and initialize to 0. Looking in the setup section, myServo.attach function with parameter 11 is used to attach the servo variable to pin number 11. Main program. In this section, we will write program to rotate servo motor. It consists of a for loop with the initial condition as 0, terminates at 180 with the increment of 1 step each. myServo.write with parameter POS is a function which orients the shaft of the servo at particular angle. Here, as the value of POS increases, the value of angle increases, and hence shaft rotate accordingly. Also, the logic to rotate the servo shaft back to 0 degree is written. When the code is uploaded on board, the servo will rotate by 90 degree from 0 degree and goes back to 0 degree from 90 degree. Following are the references. First, ATmega 2560 pin mapping with Arduino. Second, tutorial of DC motor velocity control using PWM. So, here we have successfully understood pulse width modulation on Firebird 5 using Arduino IDE. With this, we have come to an end of this tutorial. Thank you for listening. For any queries or doubt, you can post queries on the resources@eyentra.org.